What's up guys, DJ Sai here, bringing you another video today, and in this video we're going to be talking about how to use the hypergeometric calculator in order to build your deck and determine what's the best ratios to use. This is how you make so-called rational decisions for cards in your deck and what ratios to play, for example, whether to play a 1 of, a 2 of, or a 3 of. And using this you can determine what's the probability of drawing certain cards in your opening hand, what's the probability of top decking a card after a certain amount of your cards in your deck have been depleted, and things of that nature. So we'll start off with just a quick tutorial. The link is right here. I'll post that in the description if you guys want to use it. Let's go to Dueling Network and let's just check out a random deck. Alright, so for this calculator, the way you use it is there's also a math formula somewhere on this page, but it's really complicated, and it's much easier to just use this calculator and have it as your little right next to you or in your tab when you're building your deck. But population size is your deck count. Most of the time it'll be 40 or whatever, but so you play 40 cards. The number of successes in population, this is the amount of cards that you play in your deck, or the amount of copies of that card that you play in your deck. So if you play 3 copies of a certain card, you want to know the probability of drawing it. That would be 3. The sample size is the number of cards in your hand. You draw 5 cards in your hand, or well, it's not the number of cards in your hand, it's the number of cards you draw. So if you want to know, for example, the probability of drawing a 3 of in a 5-card hand, the sample size would be 5. If you want to know the probability of top decking a certain card, then the sample size would be 1. If you want to know the probability of drawing a card off of pot of greed, the sample size would be 2. Things like that. So in this case, we'll say we're going first. The sample size will be 5. The number of successes in sample is exactly what it sounds like. It's the number of cards, it's the number of the successes that you see in your hand. So if I have 3 successes in the population, and I want to know the probability of opening 1 of that card, then it will be 1. If I want to know the probability of opening 2 of that card, it'll be 2, etc. So we'll do 1, and we'll just do a sample calculation. Alright. The hypergeometric probability Px equals 1, this number, is the probability that you draw exactly 1 of that card, no more, no less. This probability, P of x is less than 1, it's the probability of drawing less than 1 of that card, but since we're only dealing with whole cards, it's the probability you don't draw that card in your opening hand. This probability here, P of x is less than or equal to 1, this is the chance of you drawing 1 of that card or 0 of that card. So, as the name implies, it's you either draw 1 of it or you don't draw it. That's that probability. This probability, P of x is greater than 1, is the chances of opening with 2 of that card or 3 of that card, anything larger than 1. And probably the most useful probability, the cumulative probability, P of x is greater than or equal to 1, this is the chance of drawing 1 of that card, 2 of that card, or 3 of that card in your opening hand. So this is 1. This is drawing only 1. This is not drawing the card. This is drawing 1 of the card or not drawing the card. This is drawing more than 1 of the card. And this is drawing 1 or more of the card. So that's how you use this calculator. That's how you think about it. Now, the question now is, well, how exactly do I use this? And I think when you're dealing with these probabilities and these numbers, it's a lot easier to think of it in terms of how often do I see it in terms of games instead of percentages. So for example, if I see this number here, my chances of seeing the card in my opening hand, at least 1 of the card in my opening hand, is 33.8% of the time. That's basically 1 in 3 games. We'll just say it as 1 in 3 games in a 40-card deck. Now, something you should probably a relationship that you should probably keep in the back of your mind is whether I reduce the number of cards in my deck or whether I add more copies of the card in my deck. Which one increases the probability of drawing the card more? Now let's say I have 45 cards and I play 3 of the card. You see the probability of seeing it, at least the important probability, seeing 1 or more of it, doesn't go down by that much. It only goes down by around 3%. Now, I can play 45 cards and 3 copies of the card, or I can cut a copy of the card, play 44 and 2 copies. I think it's easier to do it with 41 and 40. So we'll say the population is 41. Okay, well let's say I play 40 and I have 2 copies of the card. My chances of seeing it is 23.7%. Now let's say I bump it up to 41, and I play 3 copies. You see the probability goes way up. It goes up to 33%. It's basically very close to the same as if I played 40 with 3 cards. So adding another copy of the card will increase your probability of seeing the card much, much more than playing less cards in your deck. Like, the more copies of the card will predominate over the number of cards in your deck, but by far. Even if this was, like, this probability was 23.7%, even if I played like 3 copies, I think in 50 cards, I think it's still higher. Yeah, it's still 4% higher. So having more copies of it will definitely almost always predominate in a reasonable scenario. So that's basically how you think about it and how you can determine, if you want to see a certain card. Like if you want to see engine cards, like, if you're playing Tellarknights and you want to see Deneb, if you're playing Necros and you want to see your probability of opening with a Manju or a Senju, that can be, important probabilities to know. And I think ones to remember, or at least ones to memorize, and it depends if you're going first or if you're going second. If you're going first, your sample size will be 5, and if you're going second, your sample size will be 6, if you want to talk about finding something in your opening hand. But some important probabilities to know, for example, finding a 1 of in a 40 card deck in your opening hand. This is going to be exactly 15, or this is 12.5%. If you have 6 cards, it's exactly 15%. So if you want to know the exact probability of your opponent drawing that 1 of, like drawing Regeki, drawing Dark Hole, you can know the exact probability, so you can be salty about it later. But yeah, so in this case, it would be around 1 in 6 or 7 games. In the 5 card case, it's 1 in about 8 games, about 7 or 8 games, something like that. So it's kind of not so likely, but it's still, it'll still happen frequently in the tournament, at least more than a couple of times. So how do you use this to build your deck? Well, the way you can, make rational decisions about what ratio you want to use is, let's say you have a card that you want to draw 1 of but no more of it. Like, let's say, for example, in Necros, I want to draw, in general, what's an example of it? Okay, I don't think I have any good examples in Necros of a card you always, like, not really a card you can manipulate the ratios of. Like, you can say you don't want to open with 2 Valkyries, but that doesn't mean you're not going to play 3 of it. But all right, well, let's just think of a random deck. Like, let's say there's a card there's a 3 of, but like a card you always want to see 1 of, but you never want to see more than 1 of it. Like, let's see. So the number of successes in population 3, sample size 5. We'll just do this. So the numbers you can look at are, this one is the chances of seeing 1 or more of it. This is the chance of seeing more than 1 of it. So this is the chance of seeing 2 of it or 3 of it. If you want to only know the chance of seeing 2 of it, then you can just bump this number to 2. So this is a chance of seeing exactly 2 of it. This is a chance of seeing 2 or more of it. You can see that this is the chance of drawing more than 2 of it, so the chance of drawing 3 of it. It's really minute. It's I think this is 0.1%. So drawing 3 of a card is 0.1% means it happens every 1,000 games. It hardly ever happens. If it happens to you, that sucks. But it's really a mathematical anomaly, and it shouldn't. It happens, but it's not even a factor really to consider. But here we have a chance of drawing 2 of a 3 of, or well, yeah, is 3.6%. So let's say I want to. I mean, if I play 3 of it, my chance of seeing more than 1 of it is 3.6%. That's approximately 1 in every 33 games. So not very often, but it'll happen. Like for example, in an 11-round YCS, if every round goes to game 3, then you'll play 33 games. So in one of those 33 games, you'll see multiples of it. That could be an important game. Don't get me wrong. It could literally be the difference between losing on the bubble and winning. So even thinking on the fringe is something important to consider. But say I drop that card to 2. My chance of actually seeing it goes down by about 10%. My chance of seeing multiples of it goes down by 2.6%. Now I see it 1 in every 0.13%. We'll just call that 99 games. Yeah, about 99 games, 98, 99 games. So in that case, even if you played the YCS all the way up to the finals, so you played 11 rounds of Swiss, and then top 32, top 16, top 8, top 4, and top 2, so that's 5 extra rounds. You played 16 games, and say all of them went to game 3, that's only 48 games. So mathematically speaking, it should never happen. And if it does happen, it should only happen once. So this drastically decreases your chances of drawing 2 of any card if you only play 2 of it. But you also see it 10% less of the time. So you have to weigh out whether seeing multiples of the card less is worth seeing the card, actually seeing the card less. Like seeing multiples of it less is more important than seeing the card less. It's things like that that you have to consider, and that's how you use this to make deck building decisions. This calculator is also extremely useful for side deck cards, for example, and how many cards to side for each matchup. Like, let's say you have, let's say you have 5 side deck cards against a matchup, and you want to know your probability of seeing one of them. Then you would use this, and so you'll see it in your opening hand half the time. We'll just call that 50%, half the time. If it's 6 cards, you see it 57.7% of the time, so a little more than half the time. This is just your opening hand, though, and if you play a deck like Necros where you thin your deck a lot, these are where the probabilities get a little bit harder to calculate, because you can search your deck for Maju, Clauseless, Brio, Kaleidoscope, things like that, and so your deck gets thinned easier. So some helpful probabilities to know would be like 30 cards and sample size 1, and the number of successes is still 5. And so this is basically the chance of my deck's been thinned by 10 cards. What's the probability that I top deck one of my side cards? And as you can see, these are the same number because you're only drawing 1 card. Relatively high, and thinning your deck down to 30 cards, Necros usually does that in 1 turn. So you can kind of see how easy it should be for Necros to draw one of their side cards. If I have a If I have a 50 to 57% chance of opening with it, and then after I thin my deck by 10 cards, I have a 16.6% chance of drawing it in every subsequent turn. And as my deck gets thin, let's say I go down to 25, at 20% now, it just goes up and up and up. So I mean, if you haven't seen a side deck card after 15 cards, it's just really unfortunate, to be perfectly honest, because even when you're at, let's say strictly speaking, your opponent opened a floodgate and you couldn't even play for your turn, and then so you open 6 cards you can't play, and now you have 33 or 34 left in your deck. So you have that's the number immediately after you draw your 6 cards. So I mean, and it just keeps going up after every card you draw. So that's basically the gist of how you use this. Those are the numbers to calculate. This is a brief intro to it. There's some more complicated things you can talk about when you use this calculator. For example, dealing with 1-ofs versus 2-ofs. Oh, and dealing with upstart. The easiest way to use this calculator when dealing with upstart is just to consider your deck 37 cards. It's not a perfect approximation, because there's sometimes when you draw upstart and you actually don't want to play it, but that's pretty negligible. And for the most part, you can just consider it like your deck is 37 cards, so to speak, if you want to do this with upstart. And it makes your percentages a little bit better. Not by a whole lot, but between 40 and 37, you'll see a card slightly more often. Just mathematically speaking, it's just a way to optimize your deck. Whether it's worth 1,000 life points, I mean, it usually is, but it depends. That's a topic for a different video. But yeah, let me know what you guys think about this video in the comment section. That's how you use this hypergeometric calculator in order to deal with probabilities in your deck and how to build your deck a little more rationally and understand how math plays into Yu-Gi-Oh! So thanks for watching. Don't forget to like, comment, subscribe, and if you like this video, tell your friends about it. See you later.